Hello students and welcome to the Earth Moving Equipment and Farm Machinery class. Myself Shankho Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Su Degree Engineering College. So students, we started the shovel from the module number 3. In the previous two classes where in the first part we discuss about the introduction of the shovel and then discuss about the classification of the shovel, and the last class that is or the second part of the shovel we discussed on the electric shovel. Now in today's class we started the discussion on the electric shovel. So students, let's start the discussion on the electric shovel. Here is the picture of the electric shovel. Basically the shovel, these kinds of electric shovels are basically used in the mining sectors, and these particular shovels are basically manufactured by the heavy engineering corporation which is placed in the Ranchi. Now most of the popular model of them is excavator EQC 4.6. So here is the picture of the electric shovel. The model number is the excavator EQC 4.6. Excavator EQC 4.6 model. This electric shovel basically consists of these 12 components. Those are showing in here. This one is the number 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 in this way. So let's read the picture in a proper way. Here the number 1 is donated is showing the is indicated as the one is indicated the dipper or the bucket of the electric shovel. Number 2 is means is a handle. Number 3 is a crowd mechanism. Number 4 is a boom. Number 5 is a deeper opening mechanisms. Number 6 is the truck frame. Number 7 is the turntable. Number 8 is the roller circle. Number 9 is the crawler frame. Number 10 is the boom hoist winch. Number 11 this is the hoist winch, and number 12 this one is the A frame. So these are the basic main components of this electric shovel. So this electric shovel are basically consist of, so these electric shovels are basically consist of six main units or 6 main mechanism. Those are, first one is the motor generator sets. First one is the motor generator sets. Second one is the crowd mechanism. Third one is the host mechanism. Fourth one is the swing mechanism. Fifth one is the travel mechanism. Sixth one is the pneumatic control system. And seventh unit is called as the undercarriage unit. So student, let's start the discussion of this mechanism which is helps to operate or control the electric shovel. So let's start with the motor generator deck layout. Basically this is the picture layout of this is the layout of the this is the layout of the general of electric shovel. Here the principal equipment of the power which is basically used the motor generator set or MG sets, which is basically placed at the rear side of the rear side of the machine. And MG sets or the motor generator set consists of an AC induction motor, swinging generator, host generator, crowd generator, and an exciter. So this AC generator basically consists of the motor, swinging generator, host generator, crowd generator, and exciter. The AC motor is energized. So this AC motor is energized by taking the power from the high tension line or HT line, which finally drives all the generator, So all of these generators are the DC generators. The crowd generator supplies the power to the crowd motor. The host generator is supplied to the host motor. The swinging generator supply the power to the swinging and the propel motor alternatively, and that is when supplying to the swinging motor or the propel motor is cut off, and the vice versa. A control panel is placed just before the motor generator set. The host mechanism and the host motors are placed. The host mechanism and the host motor are placed before the control panel, extending up to the front of the machine floor. There are the two swinging doors. Depending upon the design, they may be placed either symmetrically on the two sides of the center line of the machine or on the left side of the machine. The, the basic specifications of the motors, generators and the exciters are the AC induction motors, which have the 250 kilowatts at 1480 rpm, DC host generator with the 192 kilowatt, DC crowd generator with the 42 kilowatt, DC swing and the propel generator with the 120 kilowatt, swinging motor with the 60 kilowatt, 305 volt and 1230 rpm, propel motor that is the 54 kilowatt, crowd motor at that is the 54 kilowatt, and host motor that is the 175 kilowatt at 740 rpm. So student, this one is the basic layout of the motor generator or the prime section, where the power is generated to maintain or control the electric shovel. Now coming to the crowd mechanism. Here students, you can find out this picture. The picture is basically denoted some 7 points. Here is the number 1, 2, 3, 4, 5, 6, 7 and 7. These 7 numbers are meaning or denote the 7 points, 7 units. Those are the first one. Here is the first one, which is describe the crowd motor. Number 2 describe the brake, denote the brake. Number 3 denote the motor pinion, and number 4 denotes the overload clutch section, and number 5 denotes the pinion. Number 6 denote the gear, and number 7 denotes the crowd pinion. It means the crowd motor which delivers the power, means the crowd motor delivers the power through the pinion to the overload clutch, and then the overload clutch deliver the power to the pinion, which is constant mesh with a gear. So in this way, power is transmitted from from pinion to the gear portion, and this gear then drives the two crowd pinion. These two crowd pinion on the both its side, which finally reciprocates the deeper stick with the help of a rack rigidly, and fixed it in the underside of the deeper stick, and braking of the motor, which is done by means of a drum attachment to the motor shafts. So students, these are the basic schematic diagram of the crowd mechanism. Now coming to the next slide, which is provide the hosting mechanism and the swinging mechanism. In the hosting mechanism, here you can find that this one is the gear, Here is the hosting drums are showing there. This one is called the brake, and in between the brake this one is the intermediate coupling. Here is the pinion shaft. Here is the electric motor. Here is the sprocket and the clutch are connected here. Given here, here is another sense of sprocket. Here is the worm shots are there. This one is the worm wheel. This one is the brakes. This one is the boom host drum, and this one is called the reducer. So these are this is the schematic diagrams of a host mechanism. In this hosting of the boom and the bucket of the shovel is performed by a proper mechanism. Here one end of the motor, here one end of the motor shaft, which is connected to the reducer through a coupling. Here one end of the motors connected with the reducer through a coupling. The reducer delivers power in a constant mesh. The reducer delivers the power in a constant mesh with the host gear, and this provides the movement to the hosting drum. It's giving movement the hosting drum, which lifts the bucket, or which helps to lift bucket. And the other end of the motor shaft, is connected to a worm wheel. Through a chain sprocket system. The boom hoist drum then is mounted on the output shaft of worm wheel combination, and thus the boom hoist drum is also rotated. In a normal case, the boom is held stationary at an angle of 45 degrees. When the power transmission transmitted from the motor to the boom hoist drum is cut off, then the bucket hoist mechanism is kept undisturbed operation. So students, these are the basic of the hoist mechanism. Now coming to the swinging mechanism. Here is a bull gear, and there is a pinions are there. This one is the vertical shafts line. Here is the oil bath. In between the oil bath there is a gear, and the shaft gears are there. This one is the motor, and this one is the brake. Here each unit has a vertical motor. With its flange resting on the reducer housing. So in the swinging mechanism basically consists of a two unit, number 1 and number 2. A vertical motor with its flange resting on the housing. At the end of the vertical motor shaft, there is a pinion which is meshed with a gear. There is a common shaft in the reducer over which both the pinion and the gear are mounted. Both the pinion and gear are mounted. Hence, the power from the gear is transmitted to the pinion, which is again in the mesh with another gear. So this gear carry a vertical shaft. And that is the output of the reducer, at the end of which is a pinion. This is known as the swinging pinion, and this is in all which is in always in condition on the with the bull gear. So then these are the basic mechanism of the basic swinging mechanism of the electric shovel. Now coming to the propel mechanism. So the propel mechanism or the travel mechanism is basically driven by a motor cylinder vehicle cum bevel reducer. A motor cum cylindrical cum bevel reducer. Here the reducer is connected to the motor by the flexible coupling, and the design of the reducer are making in this way that it can easily connect it with the motor by the flexible coupling. So the bevel pinion then receives the power from the motor through the coupling, and the bevel gear is in mesh with the pinion. Ultimately, the power from the reducer through a gearing arrangement is given to the right hand side and left hand side dog clutch, and these dog clutches are engaged and disengaged by a separate hydraulic system, and the power from the dog clutches are engaged dog clutches passes through the another reducer to arrive at the driving wheel of the crawler mechanism. So in this way propels the hold the equipment. So that's why this mechanism is known as the propel mechanism or the travel mechanism. Now coming to the next, that is the pneumatic control system. Basically this is here is a picture of the pneumatic control system. Here this one is the compressor, here is the air cleaner, this one is the air circuit check valve, this one is the bypass line, this one is the pressure gauge, this one is the tank, that is the safety valves are fitted here, this one is the bypass line, this one is the electrically controlled valve, this one is the brake cylinder for the swinging mechanism, here is the brake cylinder for the hoist mechanism, and here is the brake cylinder for the crossed mechanism, and this one is the check valve, and this one is the siren. So this pneumatic control system basically consists of a twin cylinder which is reciprocating compressor, which is driven by an AC motor, and it delivers air to the tank through a air check valve, and the tank is fitted with a pressure gauge and a safety valve. Air from the tank is then distributed to the swinging mechanism, brake cylinder, which are controlled through the three separately operated solenoid valve. There is one siren operated by air through the another solenoid valve, and the remaining end is connected to a T valve for any other auxiliary uses. So here for the pneumatic control system, the delivery pressure of the compressor is 7.0 kg per centimeter square, and the safety valve pressure that is 7.5 kg per centimeter square. So beside this, it has the undercarriage unit and the front attachments also. The undercarriage unit and the front attachments are nearly similar to the diesel Sovel. So students, here in today's class we discussion about the electric Sovel and its various mechanism. On the next classes, we started discussion about the hydraulic shovel and the applications of this shovel. So still then, stay at home and stay safe. Thank you. Thank you so much, students.